Hi, Manya. What's up, Manya?
Hi.
Hi. You have problems with probability?
Well, not really like specific problems. It's just like we have our tests this week and
Hmm.
like our teacher like he doesn't really do a good job with explaining it, so I don't really understand it.
A probability as such is hard. See, I understood what is your problem. Okay. Meaning, even if they explain it, I don't know. Let's see. Let's see how much we can get going. Okay. Do you want us to show the worksheets?
Yeah.
Bring up the one that you are finding it tough.
Well, I was honestly gonna ask if you could like just teach it from the beginning.
Yes, I will. I will. But there is something that is making you think twice, right? Can you show me that? What is that worksheet? I'm not understanding, Andy. What is making you think like that? Can you show me that topic or whatever? You see, is it conditional probability or which one? Where are you feeling dejected about geometry probability?
I can show.
Hmm.
This is a test review that we got, and
That's what. Show me, show me. That's
yeah.
what I'm asking.
Can you see the screen?
Okay. Got it, lady. They are following that springboard book, Amma.
Yeah.
Okay, I get it. I hear you. Okay, come down. See, that's what I want to know. Okay, come down. Okay. Okay, 7 and 8, based on what we did in class, you should be able to get. Come down. Abbada. Come down. What is this? 10 questions they've given. Okay. Okay, ma. Okay, we'll do one thing. Okay, I'll start from here. We'll start from where we left off. Is that okay?
Yeah.
Go up. Go up for 7 and 8. Wait. 7 and 8. Can you do this one? Geometric probability we did, right? You were good at it, I felt.
I wasn't there last class.
Did you not see the recording, huh?
I did see the recording. It's just that like I kind of understood it. I just like completely like
Lemma, see, okay, no problem. Geometric probability is the probability of something, your favorable event happening divided by all possible outcomes.
yeah.
When it comes to geometric probability, it's always area by area. Area of my favored space divided by the total area. You got it?
Yeah.
So what are they asking? Manish and Jessica are playing darts with a special target board that measures 25 by 15. If it's equally likely that the dart can land anywhere on the board, find the probability as a decimal. Now, what is that they're asking? Jessica lands on one of the two shapes. So what should you do? You tell me.
Uh calculate the area for
Area
both.
of what? Let's write it down. Area of what? I'll write it down for you. Tell me.
The triangle and the
Ah,
rectangle.
so area of the triangle and the rectangle. You have to add them basically because both are favorable, right? Divided by what?
Um Divided by the 25 by 15.
Correct, that's all. Can you quickly use a calculator? Do it. We'll check it out.
And so you would add the triangle and the rectangle, right?
Correct for money for Jessica because Jessica lands on one of these two ships. Find the probability that Jessica lands on one of these two ships. Favorable events are the two ships. You got it?
Yeah.
Good.
It's 32 over 375.
You have to check. I don't have the answer. Or send me the answer. I'll check for you.
Okay. Do you want me to send you the answer key?
Anything works. Whatever works for you.
Um,
Yeah, I get what is required for you. Let's see. I can check. Okay, you proceed. I can check, Manya. You don't waste time. You say you go to the second one. Second one, the Jessica Manish.
The
You
Manish
send
one.
it to me. Send it to me though, so I can check.
Okay. Wait, I'm gonna quickly download it.
Okay, that's fine. No problem. We'll get on to this complementary probability and all. This one I'll help you. The correct portion in the Venn diagram. Venn diagram we'll do. Venn diagram first we'll do now. Next one. Sample space means all possible outcomes. Okay, what is the sample space in this problem that you're working on? The rectangle area is the sample space. You got it?
Yeah.
Sample space is always written in the denominator.
Or I can't send it through WhatsApp. Can I send it to your email?
Yes, ma'am.
Oh, what's the email?
Oh, you want to give the email, Email Mark Rangers LLC.
Okay, it should have just sent.
Okay, man, no problem. Go ahead with the second one. I'll find out. You found out the answer?
Um, yeah, I'm doing the Manish one.
Mm.
Oh, I think I did something wrong. Hold on. So it'd be 30. Um, and then each misses both shapes. Wait, for the Manish one, would you still do that the whole area minus both of the shapes added over the whole area, or how would you?
Correct. Good job. Like this, if you figure out it's if you will never forget. Good job. Go ahead.
Hmm. 5, 2, 8. Is the answer for the first part 0.08 and the second one 0.
I'm not checking my email. Hold on.
Okay.
You go ahead. Like I just want you to be let's utilize the time is what I felt. Okay, go ahead. You share the question paper, ma. You didn't answer, you didn't
Oh,
share the key.
oh my gosh.
That's okay. I'm thinking you're sending, right?
Yeah, yeah. So the key should have just been
No
sent.
problem. I'll check you more.
Okay, do you want me to go to number 8?
Yes.
Um,
Okay.
quickly.
Okay. 0.8 and then you did. What was the first one? 0.08, right?
Yeah, and then the
One.
second was 0.92.
Good job. Next one. Are you doing sixth one? You can do, Manya.
Oh,
Sixth and
six.
eighth. Sixth and eighth you can do.
Okay, I'll first do 6 then.
Hmm.
Um, circles and squares. Now let's put the just in this. Give you so without any measurements, how would you find it?
What is it?
Um, for the 6th one,
For the sixth one, what is your question on the sixth one?
like it just says a circles and inscribed in the square, but there,
Correct. You draw the diagram?
yeah, but there's
Good.
no like dimensions to where we can like calculate the area.
No problem. You don't need anything. So what are you trying to do? What is the numerator? What is the denominator?
Um, is it just the area formula?
Yeah, what is the numerator you're trying to put? What is the denominator you're trying to put?
The circle over square.
Correct. So how will you do that?
Pi r squared
Good
over
on the numerator. Good job. Denominator
2r squared.
2r the whole square. 2r
Oh,
is the side of the square. So it will become,
the whole square.
yeah. So can you tell me the answer then? I think
Um,
you're getting it. Go ahead.
could you cancel out the r squares?
Yes, you can.
And then pi pi um, wait, so whenever like because you have to do pi divided by 4 and it's a decimal, would you go to 0.785 or would you just go to 0.78?
785 means if it is a 5, then you have to make it a 9.
Okay, so it would be 79%.
Yep, you got it. But definitely don't miss problems in geometric probability. It's so easy.
Yeah.
Got it?
So just to clarify, you would go to like the 785, right?
Correct, ma'am.
Okay. I'll do number 8. Your quintiles. Find the simplest. Mhm. Mhm. Wait, so for number 8, for B and C, or like honestly for B, C, D, E, is it that simple? Like, is it just like looking at, because I listed out the sample space, so would you just look at it and answer? Like, would it be that easy?
Come again?
So like for 8B, it says find the probability of getting heads and landing on C. Since I listed out the sample space and it's only one time that you get heads and land on C, would the answer just be 1/8?
1 minute, ma. You have to give me 1 minute time. Okay, I need to read the question. A fair coin
Yeah.
is tossed and the spinner is won. All outcomes on the spinner are equally likely. I didn't think that you would have gone to 8 now. List the sample space. Did you list the sample space, ma'am?
Yeah.
Find the probability of getting heads. You are talking about B, right?
Yeah.
Correct. Find the probability of getting heads means first circle all the ones that are heads. Okay. That is your sample space. Wait. Find the probability of getting heads and landing on C. No. Find the probability of getting heads and landing on C. Na? HC is what you need to search. In your sample space, you need to search for HC. Manya, are you with me?
Yeah.
Okay, definitely weak. Okay. Tell me.
So would the answer for
Manya, can we do it on a board together, Manya?
oh yeah.
I feel that that way I can share the screen. Okay, I can share even your question paper that you sent to me. Can I?
Yeah.
Let's do that because that way you'll be faster. I feel instead of talking abstractly. I'm sharing.
Mm.
See, can you just write on the board and explain to me so we can go ahead.
So I listed out the sample space, just saying like heads A, heads B, heads
I
C.
will do it for you. Don't worry. You did. You did. Okay, list the sample space. Okay, a fair coin is tossed and a spinner is spun. Okay, now I will write it like this, ma. Fair coin is tossed in a, put it in a column, and
Mm.
after that spinner is spun na, A B C D A B C D. This is the tree diagram.
Yeah.
You got it? So what are your sample space? HA, HB, HC, HD, TA, TB, TC, TD. You got it?
Yeah.
Find the probability of getting heads and landing on C means HC should be there. You got it?
Right. And so it would just be 1/8, right?
1/8, correct. Find the probability of getting heads or landing on C. Head is all the four. Landing on C. Is this you, ma?
Yeah.
Okay. Or landing on C is one more is there. So how many? How many favorable chances?
For C.
Yeah. This word is very powerful, ma.
Um,
Both are allowed. Getting heads is 4.
and then landing
Landing on C is
1.
1. So 5/8. You got it?
Okay.
Now find the probability of getting tails and not landing on D. You tell me. And
7/8.
Mama, please.
Oh, wait.
Getting tails and they don't want tail. T complement and a D.
So they don't want tails in a D.
I don't want tail and I don't want D.
Oh, so then 3/8.
Correct. I don't want D. This goes off. And I don't want D. This goes off. You got it?
Yeah.
Okay, see it in a different way, ma. So it becomes so easy probability. You see what I mean?
Yeah.
Don't go with uh, formulas and stuff. Okay, it's always favorable chances by the total sample space. Find the probability of getting tails or not landing on D. What do you do that? You know how they will write this? They will write this like find the probability, meaning you can add complexity to it. They want to add complexity by putting it like this, adding getting tails or means what? This one, not landing on D. See how complicated they can show you this. You see, Manya, don't get confused with all this.
I think I also need to learn like or I need
Symbols, right? Yeah, I know.
yeah.
Okay. Fine. Okay, let's do this one. Find the probability of getting tails. I'll tell you, that's all so easy. Find the probability of getting tails. Okay, we had the diagram, right? Tail, head, ABCD, ABCD. Oh, ABCD, lemma, what is that? Yeah, correct only. ABCD. Now see, find the probability of getting tails. This one. And, oh, find the probability of getting tails or not landing on D. You tell me. How many favorable chances?
Um, that would be 7, right? If it's getting tails or not landing on D.
Getting tails or landing on D. That is 7. Good job. 7 out of 8, can I say?
Yeah.
Good. Next one is you want to try this one?
Yeah.
They're
What
asked
is
P. 1 minute, Manya. Now I want you to come up with the symbols as well. Symbols are not hard. 1 minute, wait. See here. Probability of, okay, let me draw the diagram for it, then we'll understand. One thing you understand, when there is or, you use union. This is called union. When you use and, you use an intersection. You get what I mean?
Yeah. Do you have like a or do you think I could just search up on Google like for all of the symbols?
Illa, wait, ma. What is that you won't understand? Meaning, these are a part of sets, ma. These are a part of sets chapter, okay? Problem is they don't cover in the US syllabus at all, sets.
Hmm.
Okay, sets comes as a part of linear algebra, which only math kids take later. Okay, but you want to know this symbol. Okay, let's see. Let's see. You don't, Manya, after this class, you should be able to, I feel very honestly, but let me see, since you're asking me, right? Hold on, let's see together quickly. I feel like you don't need it. Let's see, set symbols. It's not, I understand where are you coming from, why it is so, you're so messed up with geometry now, I understand, but it's not that hard. Uh, let's see. This is better. This is waste. This is better. Yep. This one is very good for Venn diagram. Can I send it to you?
Yeah.
This is exactly for the Venn diagram, other questions that you have here. So where do you want me to send it to you? Here?
Yeah.
This is very good. This is for only sets. This is for only Venn diagrams. Okay, and there was one more that I wanted to show you. No, this is all waste. Probability, yes. You don't need 3 Venn diagram. Okay, that's it. That's good enough. You got it?
Yeah.
Can we move on?
Yeah.
Okay, now can we go back to your sheet, Amma?
Yeah.
Okay, what did we leave? Wait. It was in my email, right? Okay, go ahead. What do you want to do?
We were on AF.
8F. Okay, let's see. We'll go from 8F. Okay, 1 minute, Manya. Before we go there, right? Please understand, okay? Meaning this is not hard, okay? Intersection meaning if I want tail, event one tail and A to happen, I will put an intersection. Tail or A to happen. You read it like that. Or A to happen.
Mhm.
This both should happen, na intersection. You got it?
Yeah.
Think about this. I have a set 1, 2, 3, 4. I have another set 2, comma 4. Okay. You got it? So here A union B is 1, 2, 3, 4. Union B means both together when I add it. It's 1, 2, 3, 4. A intersection B is 2, comma 4. You got it?
Yeah.
Intersection means these two are the commonality.
Okay.
Okay, intersection means both should happen. Now, what is this? T complement is head. Head complement is T. Am I making sense?
Yeah.
Whenever you see this complement or T dash, right? I think they don't use this. This is what they're using in their Springboard book.
Yeah.
Okay, this complement means tail not happening. They don't want tail. You got it?
Okay.
H complement means they don't want H. You got it?
Yeah.
Meaning H not happening is H complement. Can we try? Can I try? Can I go on?
Yeah.
Okay, let's try this one. Which one? See, honestly, I like this, but the thing is my time, very frankly. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8. Which one were we on my? This one, huh?
AF. Yeah.
Okay. Probability of heads and A. Probability of heads and A. First, let's do this. If you don't do this, it's going to be hard. Please draw this, okay? At least a Venn diagram you should have or a tree diagram you should have. Now,
Wait, this is like not even that hard.
oh, this is not even that hard. You can deal with it.
Yeah, because it's both just 1/8, right? Because the probability of getting heads in A is the
Heads,
same
heads
as
and A is what?
1/8.
1/8. Probability of tails and C? 1/8.
1/8.
Yeah, correct. You got it? How about this? Randomly we'll do. Is P of tails and B or C? See?
So
Tails and B, 1/8. Or means you need to add.
plus,
C means 2/8.
wait, how's it 2/8?
Because it's just
Oh,
or
oh,
C.
or
Here there is one, here there is one. So 2 out of 8. You got it?
same as PD. So PD would just be
So P
two
of D, yeah.
eighths.
2/8, correct.
So then it would not.
They're not the same, correct. Got it, Ma?
Yeah.
Can we move on?
Yeah. Could you do number 9? Because I don't know how to do Venn diagram.
Wait, Ma, you need to find, you need to understand Venn diagram. Wait, which is the starting point? I'll check. Let's do, this is a starting point. We'll do this one and then that one. Can
Okay.
we do this?
Yeah.
But you understood now, right?
Yeah.
Now, see, now that you know this, right, Manya?
Yeah.
We are going to attach this to the Venn diagram too. First, we'll do first one, then the second. Ma, your review is very nicely given. In the sense, very nicely given in the sense it follows an order. So we'll do one by one. Okay, wait. 100 students at Nata. Oh my gosh. Something shifted, right?
Yeah.
Okay, here. Okay. 100 students at Nathaniel High School are represented below. The set of students who shuffleboard. Okay. Shuffleboard means yes. Okay. And then the set of students who play kazoo. K. Okay. Seema, in a Venn diagram, these are the people who shuffleboard. Okay. These are the people who kazoo. You got
Yeah.
it? There will be people who do both.
Yeah.
When I talk about people who shuffleboard, right, it will include the entire circle. Okay? When I talk about people who kazoo, right, it will include the entire circle. When I add both the people who kazoo and shuffleboard, right, what would happen? Are you adding the two circles?
Um,
When I add the people who shuffleboard, when I add the people who kazoo, what is getting duplicated? This piece will get duplicated. You are adding unnecessarily this twice. Are you getting it?
yeah.
Okay, that you got it. Good. 100 students at Nathaniel School are represented below. So the entire rectangle is 100 people. Why? What is this space then? Do you understand what is this space?
People who do neither.
Ah, correct. Now, good. Now, for each answer, include the probability note. What is the probability that a student plays shuffleboard and does not play kazoo? He plays shuffleboard. Okay. Okay.
So it would just be 22, right?
Correct. Now here how they have given is this is the space that is 22. You got it?
Yeah.
Now, next one. So what is the probability that a student plays shuffleboard and probability means it has to be a fraction. 22 by
100.
100, correct. You have to simplify and tell, okay?
Yeah.
Probability that a student plays shuffleboard. Probability that a student plays shuffleboard or the kazoo. The or means what will you do? Both are favorables. So what will you do?
Add.
Yes, 22 plus. That's a little tricky. What will you do?
Wait, so
They want to know that a student plays shuffleboard or kazoo? Mhm.
What did wait?
I'm getting confused. A shuffleboard or the kazoo? Mm.
Wait.
Uh,
Wait, no, that makes sense. Because
go ahead. What?
22 plus 49 plus 19 is only equal to 90. So that means 10 people do neither.
Good. So what is the C answer? Good job. What is the C answer?
10,
10 out of
100.
100. What is the probability that a student plays shuffleboard or the kazoo they're asking? So definitely this is in there. This is in there. You got it?
Yeah.
Um,
Wouldn't 49 also be in there?
wait, I need to read it again. What is the probability that a student plays shuffleboard? Mm, let's I just want to verify the answer once more. I don't want to commit to you. Wait. Why I am a little hazy about it is I'm not. See, because both they did not mention, right? You can add 49. What is the probability that a student plays shuffleboard or the kazoo? Okay. If they had asked, if you had wanted to add 22 and 19 only, right? They should have mentioned what is the probability that a student plays only shuffleboard or only the kazoo. Am I making sense?
Yeah.
That time you will add 22 plus 19 divide by 100. Here it's not the case. They are okay if the student plays kazoo. That's enough. So you will have to add the duplicate the intersection. This area is called intersection. This area is called intersection. Got it? So you will have to add. They are not bothered about whether the kid only plays that. They're not bothered about it. If they had been bothered, student plays only shuffleboard or only the kazoo. If they had asked like that, I would do only this. You got it?
Yeah.
But here, the only word is not there. So we will go ahead and add all the three. Make sense?
Yeah.
Okay. Now let's go back, Amma. Let's go back to our. Amma, are you getting a good picture now?
Yeah.
Okay, now go ahead. What is going on? Okay. Now you know first one, right? Second one, let's try. What is P of A? P of A. Correct portion of the Venn diagram. P of A is what?
Wait, what is
P
A?
of A means don't take it as S and K, that's all.
Oh, okay.
We'll do there. We'll do there. So it's easy for us to check as well quickly together. Mm, okay, we'll do it separately, ma, then check. Come on here. In that Venn diagram itself, we'll do. So, Seema, yes, probability of S is this whole thing. You got it?
Yeah.
K means what?
Um, just okay.
49 plus 19, correct?
Yeah.
Okay, this is K. Now, can you talk to me about P of S intersection K? Let's do here. And then we can check the answer too.
That's intersection.
Okay. Intersection means what?
Just the middle part.
Yeah, you got it?
Yeah.
And then the next one, let's see. This is a, okay, S union K. Union K means method union.
Everything.
Everything, correct. You got it?
Yeah.
Okay, now let's go ahead with the, okay, till D we completed already. Okay, I'll draw it for you again. Yes. Okay. Now, see, they're wanting, think of it nicely and then answer. A intersection B complement. Wait, I'll write it for you in a way we need it. A means S and K. We will do S and K. Go ahead.
So no S. Oh, sorry, no K.
No K. No K is where
So none of
No K. No K means this ma. K complement is this.
Oh,
K complement is this. Definitely K complement is this. You got it?
yeah.
K complement intersection, yes. S is where? This
Right.
is S. S is this.
Yeah.
What is the overlapping part? You understand, ma? Overlapping part is this one. Do you get it?
Yeah.
Clear, huh?
Oh, okay. I see. Okay. So it would just be the green part.
Correct. You got it?
Yeah.
Now, can you tell me, other than this, I'll give my own, but you understood the concept here, right?
Yeah.
It is not that hard at all, these things, okay? Okay, how about S complement intersection B? S complement intersection B. Let's do. Which
Wouldn't
you
that
did.
just be K then?
In the S,
Like, or just this part?
show me. If you want to show, you can show. Correct. Just this waxing moon. Got it?
Yeah.
You understood nicely now?
Yeah.
Okay. Now let's go to the other one. 9. 9 or something like that, right? See, this one should be very easy for you now. Complete the Venn diagram so that it represents the number of students in the school is 450. See, they have put a total of 450, correct? The
Yeah.
number of students who have a phone or who have a bicycle, or who have a bicycle is 425. That you can't do. Okay. So wait, because that's a little, it involves phone, bicycle, phone, this coinciding part and bicycle. It involves everything. You can't do anything about it. Okay. The number of students who have both a phone and a bicycle is 50. So what will happen? You tell me. This is phone, bicycle, man. We are going to fill it up. Okay. Total is 400. Okay. Now, 450. Sorry. Mani, are you following?
Yeah.
Number of students who have you can't do anything about this. Don't think deeply because it involves phone, it involves bicycle, it involves intersection. Don't worry about it. Okay, let's go to the single ones. Number of students who have both a phone and a bicycle, would you be able to take care of that? Where will it go?
Um, both the phone and a bicycle.
Hmm.
Um,
This
um,
is phone, this is a bicycle, right? Both the phone and a bicycle means
in
intersection.
this middle.
Middle. So this is 50. You got it?
Wait, 50.
50. Sorry. Yeah, 50.
Huh? Oh, okay, okay. Okay.
The number of students who have a bicycle is 135 means how will you do?
Um,
135 is what?
is the intersection plus B.
So what is B alone?
Um, 130 minus 50.
135,
Or
135,
135 minus 50.
135 minus 50, right? So this is 85.
Yeah.
Makes sense?
Yeah.
But the thing is, there should be something else as well. Some information is missing. Um, okay, the number of students who have, see, this one is going to help you out. 425 means addition of this, and this is 425. So from 425, can I subtract the 85 and 50?
Yeah.
425 subtract the 135, what happens? 290. You got it? So this space is alone 290. Make sense, ma?
Yeah.
Now you'll be able to calculate the probability.
Yeah.
No, let's find out. Let's see whether you understood. This is phone, this is bicycle, right? Can you elaborate me the area which involves probability of phone and bicycle complement? Which is the area?
Is that intersection?
You think and tell me. I want the phone intersection bicycle complement.
Um,
Start coloring, then you will understand seriously nicely.
okay, wait, so bicycle. complement. Ugh. Okay. Then,
Go ahead.
um, so B is so
Yes, ma, tell me.
would it be that?
Correct. Now you got it. See, only when you color, you will get it initially. You understood, huh?
Yeah.
You're correct. But so that whatever number comes there divided by the total. Makes sense, ma?
Yeah. So 290 by
I
450?
see there. That's the answer there.
Oh, okay.
Okay, I gave you the thing here. I wanted you to circle and show me. Did you understand, ma?
Yeah.
So basically, probability is not hard at all as you think.
Yeah.
Mm-mm. Uh, okay, suppose if they ask you, what is the probability that the student will have a phone? See, these are probabilities. Okay, I'll draw a Venn diagram. Hold on. The probability of this part only indicates this part, lady. Please understand.
Yeah.
This part is this part.
Wait, why are you doing it in decimals?
Because probability can be percentage or decimal, right? Number of
Oh,
students is 290. 290 divided by 450, they did.
okay, okay.
You got it. With Venn diagram, they can do however you want, you can do. You got it, huh?
Yeah.
So now tell me, what is the probability that a kid will have a phone?
Oh,
He having a phone is what should you get added? These two you should add. You
wait,
got it?
6. Oh, yeah.
He having a bicycle, what should you add?
Wait, which one?
He having a bicycle.
0.189.
Not really, right? You have to add both.
Oh, okay.
You got it?
Yeah.
What is the probability of B complement? You tell me. What is the
Um,
probability of B complement? What and all you need to add?
uh, 0.644 plus 0.056.
Yes. What is the probability of P complement?
Um, 0.189 plus 0.056.
Did you get it?
Yeah. So
What
what?
is P complement? Kid
I,
not having a phone. What is
I,
B complement? Kid not having a bicycle.
I have a question.
Yeah, go ahead.
So whenever they ask for any type of complement, you wouldn't include the intersection, right? Because that still includes like them having a phone or them having a bike.
Absolutely yes.
Okay.
For your question, P complement is the area this ma. You get it? So the intersection does not come into picture at all. You got it?
Yeah.
So if you go methodically, everything will be easy. You understood?
Yeah.
Now, most of it are easy now. Do you see it?
Yeah, most of them are easy.
Easy. So it's just that you were very afraid, right? Though
Yeah.
I can see it. That's what. So here, when you think about it, now you know what? I want you to go through the Springboard book, do the problems, and come back, ma.
Okay.
Okay, this one I want to go over. Okay, this one is a little tricky. Can I help you?
Yeah.
Elizabeth Grant and Catherine own a smoothie shop. The table shows the number of strawberry blueberry smoothies bought by customers by age group. Um, I don't want. I'll do one thing. I want a question table. I don't want this table. Let me see. Wait, ma. Children, adult total, correct? Strawberry, blueberry total. Now 10, 9, 12, 15. That's all given, right, ma?
Yeah.
So these three own a smoothie shop. Table shows the number of strawberry and blueberry smoothies bought by customers by age group. Okay. How many smoothies were bought in total? Yeah, that's easy to calculate. Amma, these are called what to say? Multi-way tables, huh? These are called multi-way tables. Okay, one is, see, Elizabeth Grant and Catherine own a smoothie shop. Okay, the table shows the number of strawberry, blueberry smoothies are given here. Okay, when you go to the total section of this tells you the total of strawberry, this tells you the total of blueberry. This tells you the total of children, this tells you the total of adults. You got it?
Yeah.
Once you think about it, right? This one, the corner square, is the total of the row and the total of the column.
Yeah.
So the smoothie shop is dealing with the total of this many smoothies. You got it?
Yeah.
So now, once you have these cells filled in, what and all you can fill? You can fill in this, 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 you can fill in this. Correct?
Yeah.
19, 27.
Wait, so then after you fill in the table, wouldn't it just be whatever the question is asking over the total area?
That is the problem is this symbol. You know what is that symbol?
Um, no.
That's the deal. See, this symbol is a tricky part. Okay, let's not deal with this. P of S is what? Probability of S is what? Probability that it's a strawberry smoothie is what? 22 out of total 46. You get it?
Yeah.
Probability of C is what? Probability of it being a child is what? You tell me. 19 out of?
46.
That is easy. You got it?
Yeah.
But probability of A given S has occurred. That is how you read this. Probability of A. Probability of A. Probability of A is 27. But that's not the answer. Why?
Oh, so it's how many adults in strawberry?
Given strawberry has occurred, you are being told the denominator is correct. It is a strawberry smoothie. It is a strawberry smoothie. Okay, so you will have to look into that column. Okay, what is the probability of it being an adult? So 12 out of a 22. You got it?
Yeah.
See, this is where you need to be careful when you have that pipe symbol. Pipe symbol says this is the column you need to see, and that is your denominator. You got it?
Yeah.
Here, then tell me probability of B by C. They have given C. They have
But
given that this is your denominator. You got it?
yeah.
But probability of B in that row you need to see. You got it?
So it wouldn't be 9 over 46, it would be 9 over 19.
19. That is because we are assuming C has already occurred.
Okay, okay.
You got it?
Yeah.
This number 3 is dependent probability.
Okay.
But Manya, having said that, dependent probability is not that easy. Dependent probability is easy only when they give you the table.
Hmm.
Okay. Do you see what I mean?
Yeah.
Here, there is 3 blue, 3 red. Here, okay, that is a. Now, I pick a ball, no replacement. Pick. Okay. What is the probability of blue and a blue? This is dependent probability because first time when you pick, right, the ball numbers get reduced. Do you see what is the probability of blue at first? 3 by 6,
3.
by 6, right?
Yeah.
In the second pick, what would happen? You tell me.
It would be
You already picked the blue. So what happens?
oh,
This will become 2 blue,
2
3 red.
over
Yeah.
it'd
So
be
what?
2 over 5.
See, this is what is dependent probability.
I see. Okay.
Here, you are trying to find out the probability of B given B has occurred. The first B has occurred. Now you're trying to find the probability of B, that is 2 by 5. You got it?
Yeah.
This pipe B means this event has already occurred. Assuming that, you have to find the probability of this. You got it?
Yeah.
Pipe symbol is always for dependent probability. Am I making sense?
Yeah.
Nicely, right?
Yeah.
Wait, it looks good, but I don't know whether you'll be able to, right?
I think I'm gonna do the review today and then I'll go into the Springboard geometry book and do the problem.
I can give you problems as well, ma.
Yeah.
Okay.
Our test is on Thursday, so I also have time to like,
That is true. That is so true. Okay, can you do one thing for me here?
yeah.
See, two-way tables. These are multi-way tables, I said, right? These are two-way frequency tables. No, no. In the class as well, I'll cover. I have covered only geometric probability, right?
Oh, okay.
The class as well will. Let's do that. How about, can you tell me, what is the probability of D intersection S? D intersection S. What is the probability?
The intersection. So,
Mm-hmm.
um,
There
so
is no pipe symbol. So you can be, you don't have to be paranoid. D intersection S means what? D should coincide with S. Which one, which number should I pick it up?
25.
35. Out of total is 70. You got it?
Wait, but didn't for the other one, didn't we just do like the total of the row?
Yeah, we did that because they had asked for P of D or P of S. It's easy.
Oh, okay.
P of D or P of S means it's easy. P of D is this, P of S is this. But they've asked P of D intersection S means 25 out of a total. You got it?
But then for the first question, wouldn't that one be wrong? Because they took,
P of D, yeah. P of D is 43. 43 by 70.
oh,
Correct.
okay. Okay.
Huh?
Oh, and then for like number 3, that's when you take the only total
Yeah,
one.
see, that is the deal. This pipe symbol is killing,
Okay.
meaning S has already occurred. So this has already occurred. Your denominator is 35. That clearly tells you.
Okay.
You got it?
Yeah.
In that, what is the probability of D? 25 by 35. Make sense?
Yeah.
Ma, are we very clear?
Yeah.
Okay, what is the probability of F by C?
F by C.
F. C has already occurred.
So then 17 over 27, right?
C has already occurred. Means, yeah, 27 is your lower. No, I'm slow, ma. Wait. Probability of F, correct. You got it?
Yeah.
Yeah, see, here as well. You got it?
Oh, yeah.
What is probability of D intersection C?
The
D. Oh, it
intersection.
can be only cats and dogs. D intersection C.
So,
D union. D intersection C is 0.
oh, yeah.
You see, D union C is 1. You know why? It has to be cats or dogs, right, ma?
Yeah.
So it has to be this 27 plus 43 divided by total 70. Union means together. Make sense?
Yeah.
Yeah, but it's not as hard as you think it is. You know that, right?
Yeah.
Okay. Wait, I want to go over. Did I miss anything here? Yeah, this one is a little tricky, lady. This one is a little tricky. You know what? The other day we saw this in a competitive math problem for Hamsini. This one she did not solve it correctly. Let's see. See, that's why, Mamanya, sometimes competitive math really helps because you get introduced to it so early. That's okay. But I'm just saying, okay, I'm just talking to you as a friend. Sean Johnson often studies his current events in geometry class so that his classmate Nikit can help him. Nikit is a good student who pays attention. So, Seema here, so he can only help Sean 40% of the time. Okay. Okay. Make a tree diagram. Better you make a tree diagram in this case, okay? Now, seen can help, seen can't help. Got it, ma?
Yeah.
This is seen can help is 40%. Seen can't help is 0.6. Am I with you?
Yeah.
Okay. After seen helping, this Nikhil can get good grades or not get good grades. Am I making sense?
Yeah.
So, seen makes a good grade 85% of the time if he helps. So, him helping good grades. This is good grades, this is bad grades. You get it?
Yeah.
So, this is 85% of the time, this is 15% of the time. Am I making sense?
Yeah.
I feel like this one we have to go through again 100%. Okay. If he does not get help, scene makes good grade 35% of the time. So, what happens here? Good grades is only 35%. What is bad grades?
The other.
65%. You got it?
Yeah.
Now they are asking what is the probability that scene will get a good grade? You tell me which and all should be taken into account.
Wait, that he makes a good grade?
Good grade, yeah. This one should
That
be taken into account.
it helps him.
This one, right?
Yeah.
But the problem is for him to achieve this, you need to multiply these two.
Wait, but in the problem, doesn't it already say Sean makes a good grade 80% of the time, 85% of the time?
When Nikit helps.
Yeah, but in B it
When
says
Nikit helps means this has to happen and this and this should happen. So you have to multiply these two to get the decimal here.
okay.
You got it. Similarly, for this one to happen, you need to multiply this and this. You write down the decimal here. Then add these two. That will be the chance of him making a good grade. You got it? If you multiply those two, you get 0.34. If you multiply these two, you get 0.21. So you have to add these two. That is the possibility he'll get a good grade. You got it?
Yeah.
Am I making sense?
Yeah.
Okay. Did they explain all this, Amma, school lab?
They like the thing is our teacher like he'll give us all these packets, but he'll just teach us the problem. He won't teach us the concept.
Oh, so you're not following.
Yeah, like I would only know how to solve it for like a certain problem, but like if you would give me a different problem, I wouldn't know.
Okay. Amma, this I am not confident of you doing, ma, honestly. Okay.
I think I just need to understand the tree diagram for this one.
Amma, I'll do it in class, this one.
Okay.
I'll do definitely do more problems in class. Okay. This is quite an important concept which can come in PSAT as well.
Okay.
We'll do this in class. Okay. This one, the next one you should be able to do based on what we discussed now. You see?
Yeah, I can do it.
But do you understand what are these? What is this independent event or dependent event? You don't know all this, right?
No.
You don't know, right? 1 minute, wait, ma'am. Then use it to determine P of okay. A intersection B. Oh, okay. I'll do one thing, ma. In the class, I'll cover independent, dependent. Anyway, this is what is next upcoming. Independent, dependent. Okay. I'll cover these two today. Am I making sense?
Yeah.
If I cover independent, dependent in two-way tables, one or Venn diagram, I'll cover. That's more important. Okay.
Okay.
If I cover independent, dependent, these two you should be able to solve.
Okay.
You see what I mean?
Yeah.
And I'll also go over the Venn diagram and the symbols once more. Irma, 1 minute, wait. Other, see, these are dependent probability that will get covered. This one I'll explain the symbols. This you're good, but this is not enough. This will take a little bit of time. I want to clearly explain this one to you.
Okay.
Which one I'll tell you? This one, I don't want to explain this problem just like that. You see, it has got more to it. You need to understand why it is independent and dependent. See, in this ball, right? In this ball example that I gave you, right? 3 brown, 3 red, right? Right?
Yeah.
In this one, you pick and pick. Is this dependent events? Both one, picking, picking. How about 3B3R? If I have pick, replace, pick. What type of event is this? What type? This is dependent on this, huh? Independent of that. Do you realize it or no?
Mm.
You're picking a ball, picking a ball.
No,
When you pick the second time, the structure of the bag changes. Do you
no,
realize it?
not independent.
This is dependent. Correct.
Yeah.
Here you pick,
You replaced it.
replace it, pick.
So independent.
Independent probability because this is completely independent of this because you put the structure of the bag the same. You
Okay.
got it?
Yeah.
So in this case, picking blue, they are independent events. I can just multiply two probabilities here. You got it?
Yeah.
Here I can't, I'm sorry, here I can directly multiply. Independent means. Okay, if it is dependent, I can't multiply. This will change. Why? The structure of the bag changed, right?
Yeah.
So I have to write it like probability of blue, assuming blue was already picked. Am I making sense? See,
Yeah.
using the pipe symbol, I'm making it a dependent probability for the second one. Did you see, ma?
Yeah.
Are you getting a gist of it?
Yeah.
Okay, I'll explain this in class, ma, 100%. Don't worry about this. Okay, this will
Okay.
also help you solve this. Dependent probability, you need more inputs. Okay, but geometric probability, you're good, right?
Yeah.
Venn diagrams, I feel you're good, right?
Yes.
Notations, you're good, right?
Yeah.
No, you don't need to say yes, yes for me. I'm just asking.
Yeah, I think it's just that those last like the Nicketh problem that I think I need to look
ಇಲ್ಲ, ಇಲ್ಲ. 4 and 5, I will work in
at
class.
4 and 5.
Today, I'll work in class.
Okay.
Got it? That way, you get the benefit of everything.
Okay.
Okay, yeah. But
Yeah.
you want more problems now? I'll give you more problems. Otherwise, the Springboard book is your guide. Based on the review, I'm saying if you thoroughly go over Springboard book, you'll get all the problems right.
Yeah, if you can you send me more?
More questions.
Yeah.
But my I will give. I don't mind. But Springboard or the notations may not be there. You got it in the problems that I
Oh,
give
okay.
because that book is a very different one.
Okay.
With this one, they are completely following Springboard. Springboard, there are a lot of problems, the same thing. Okay,
Yeah.
I'll at least send the page numbers. That's okay?
Yeah.
Yeah, I'll do that.
Yeah.
Okay,
Okay.
I'll stop here.
Yeah. Thank you.
But is it a little better now?
Yeah, it's much better now.
Okay, good. But after the class, you'll feel so much better.
Yeah.
Okay, va? Bye, ma. Bye.
Bye.
How are you doing overall?
Overall, I'm doing okay. And like, yeah,
What? Yeah.
I just think that like the teacher, like I know I shouldn't blame it on the teacher, but like sometimes when he only teaches the problem. So then when it comes to the test, like it gets really confusing.
And you get a different problem you're not able to solve.
Yeah.
Anna, okay. So in the group you're not understanding,
The group I'm understanding pretty well,
Mm.
but like sometimes I feel like whenever like the problems that you give in the group are like much easier.
I see. Than the ones that are coming for the class, huh?
Yeah.
I see. I take it. I can see what you're saying.
Yeah.
So what you're confronting in school seems a little harder.
Yeah.
We'll see. I'll also think what to do.
Okay, yeah.
We cover the harder piece, right? Hmm. I'll see.
And
I'll see.
if you have any like some, because I want to start prepping for the semester exam pretty early.
Mm.
If you have anything that
Oh,
could
yes.
help.
For probability, huh?
No, for like I'll send you the specifics, but like this whole semester.
Please send, ma. Send. I will send for you.
Okay.
Okay, yeah. Anything else?
No.
Okay. Bye bye.
Bye.
Bye bye, ma. test வேணுமா?